Did you know that 40% of the average household energy bill is due to heating and cooling systems? Central air conditioners, heat pumps, resistive heaters, evaporative coolers, electrical resistive hot water systems, heaters, and more are all silent contributors to an unnecessarily high energy bill. The heat that the sun radiates to Earth is held in Earth's atmosphere. Only 5% of energy is directly reflected back into space. This is called the greenhouse gas effect. It keeps our Earth warm at 15 degrees Celsius by maintaining this long-term energy balance to sustain life. The process of which the majority of our electricity comes from is burning fossil fuels. Burning fossil fuel releases carbon dioxide and nitrous oxide into the atmosphere. These gases have particularly long infrared wavelengths. Research has suggested that the atmosphere is absorbing more of these long infrared wavelengths than it typically should from the surface of the Earth. The concentration of these gases has increased over the last 100 years as our demand for fossil fuels has increased exponentially, with increasing demands for technology and energy plants. This means that the atmosphere is being polluted, not allowing heat to escape. This in turn radiates the heat energy back to Earth, slowly warming the globe. Now, what if there was the possibility to reduce home energy consumption for heating and cooling houses to almost zero? Is there a possibility of homes being built that do not require any heating or cooling at all? Austrian physicist Dr. Feist built the first passive house in 1991. Passive houses are energy-efficient homes that require little to none mechanical heating or cooling. Passive homes take advantage of the natural climate, body heat, and appliances to maintain thermal comfort. There are 5 elements to building a passive house: proper sealed insulation, elimination of thermal bridges, properly glazed windows, window orientation, and heat ventilation devices. Insulating materials in passive design homes prevent heat loss by conduction in colder months and prevent heat gain by conduction and radiation in warmer months. Passive houses have very thick walls. Floors and walls that are made of materials that absorb and store thermal energy are used for naturally heating and cooling homes. Large sums of energy are needed to change the temperature of high-density materials such as concrete, bricks, and tiles. This means that the walls and floor take longer to heat up on hot days and longer to cool down on cold nights. An important aspect of maintaining an insulated environment is regulating and reducing air leakage as much as possible. Air leakage accounts for 25% of heat loss in buildings. High-performing tape creates an air barrier to avoid any air leakages to seal the insulated walls. This is to avoid cold air from the outside to leak into the building. Another factor to reduce is warm air leaking outside the building. Thermal bridges are like roads for thermal energy where warmth can travel through walls. Proper insulation maintains a heat environment and eliminates air to leak inside or to travel out through thermal bridges. This is done by adding additional jagged layers of insulation fixed to wall frames, like inside the walls. Another majorly important element of a passive house is windows. Windows are water, air, and vapor-resistant barriers which also insulate the home. Passive houses aim to utilize double or triple glazed windows. Insulating glass stops the transfer of heat by conduction. Double glazed glass reduces the amount of heat conduction by having air between the 2 panes. Air is a poor conductor of heat, which means that much less thermal energy will be transferred through a window that is double or triple glazed. In order for windows to be an effective form of temperature control, they must be oriented in relation to the house and season correctly. House windows must be oriented so heat can get in during winter and shade is provided for the summer. In summer, there must be enough shading over the windows to not let heat in. Effective shading includes overhanging eaves, window awnings, shutters, blinds, pergolas, and large trees. Finally, passive houses have devices to regulate the flow of fresh air, without compromising the heat conduction system. Low energy consuming machines are installed into the house with fans sucking in air from the outside, feeding into a cross-flow heat exchanger, providing the home with fresh air without having to open any windows. All of these factors not only help preserve the environment, they also save you money on your energy bill and you get healthy and clean air.